Hello, today we're going to do problem 913. I've modified it to make it an even cash flow problem so we can do all of our examples. And it can be found on page 367 and 368 of your text. So what we're going to do is our major modification is that we are going to assume that the year one net income of $93,000 is the same throughout the entire life. So all the way to year 7, we're going to have $93,000 of net income each year. So in this case, we are buying a machine. It costs us $450,000 in year 0 to buy it. And they were very nice to us that they gave us the income statement. So our net income is $93,000. And in order to get our annual cash flow, which is step 1 of calculating the net present value, we have to add back depreciation. Depreciation expense on this asset is given. It's $50,000 each year. So our annual cash flow then would be $143,000. As I told you in class, I will be asking you to calculate straight line depreciation. So just in case you forgot, if you needed to calculate straight line depreciation, you would take the cost, which is $450,000, and reduce it by the residual value, which in this case is $100,000. So now we have to depreciate $350,000. It's a 7-year life, so that gives us $50,000 of depreciation expense each year, which is the same as they gave you in the problem. Okay, so that completes step 1 of calculating our net present value, which is getting the annual cash flow, $143,000. Step 2 is determining the required rate of return. In our case, it's given. It is 14%. But obviously, in real-world scenarios, you may have to look to weighted average cost of capital for your industry and other sources to get that rate of return. All right, so I'm going to move the page up. So now we can do step 3, which is get our present values and evaluate the situation. So in year 0, I said our cash flow was $450,000 to buy the machine. It's a negative cash flow because we're paying them for the machine, so that's cash out of our pocket. Because it's in year 0, it has a present value factor of 1. We don't have to discount it back to current day values at all. So the present value of $450,000 paid today is $450,000. The annual cash flow, as we previously calculated, was $143,000. That's paid every year from year 1 through year 7. Therefore, it can be called an annuity because it's equal payments, equal rate of return, and equal periodic intervals. So we can use the table on page 358 of our text. So using this table, I go down the rows to period 7 because we have 7 years, and I go across to 14% required rate of return. And I find the annuity value that intersects those amounts. That value is 4.2883. So when I multiply that by my cash flows, I get a present value of $613,226.90. But I'm not done yet. I can't forget about the residual value, which is $100,000. And that is one payment in period 7, so it's one payment 7 years from now. Therefore, I need to go to my single sum table, which is found on page 357 of your book. Go down to period 7 and across to 14%. When I do that, I get the factor 0.3996, and when I multiply them, I get $39,960 as a present value. So this is the present values of these cash inflows and outflows, but in order to get the net present value, I must add up my future cash inflows and subtract my first cash outflow. When I do that, I have a positive $203,186.90. Because it's greater than 0, we'd give it the thumbs up, which means accept this investment. Continuing on with the modified problem 913, I also like to review how to calculate the internal rate of return. calculating the internal rate of return is fairly simple. It's the initial outlay divided by the annual cash flow. Our initial outlay was $450,000, and our annual cash flow as previously calculated was $143,000. Therefore, we get a number of 3.1469. But we're not done yet. This is not the internal rate of return. We have to look up the value in the present value tables that is closest to 3.469. Because this is an annuity, we get equal payments. We go to the table page on page 358. And when I do that, I find that for period 7 periods, value 2.8021 is closest to 3.149469. Therefore, IRR, internal rate of return, is approximately 30%. So finally, in order to decide if we're going to accept the investment, we have to compare the 30% internal rate of return to the 14% required rate of return, and since it is greater, we would accept the investment. Our final two concepts for chapter 9 that we were covering in detail are the payback method and accounting rate of return. So let's do these for our modified problem 913. So the initial outlay is $450,000. We have $143,000 of annual cash flow. So to calculate the payback period, it's 3.14 years until we make our investment back. Accounting rate of return is average income over average investment as defined in your book. So if the net income every year was $93,000, we have the first year, year 1 net income $93,000, year 7 year income $93,000, divide by 2. And average investment in year 0 we paid $450,000. At the end of the investment we paid nothing, so we divide that by 2, and we come up with $93,000 over $225,000, which is approximately 41.3%. And that's it for my modified problem 913. Good luck with your studying and on the quizzes and finals. Thanks.